Hello and welcome to Algebra, Unit 3, Concepts 4, 5, and 6, Lesson 2. Today's objective is scholars will graph quadratic functions using vertex form. So, first thing we do is understand the graph of g of x equals x squared plus k. So basically what happens when I add something to my graph. So we have the graph x squared minus 4, and we're looking at how it compares with f of x, which is just x squared. So you can see the two graphs have the same axis of symmetry. Remember, that was one of our things. We have our axis of symmetry right here. Each point is translated down 4 units. So this minus 4 responds to it being down 4 units on the corresponding points. Finally, the vertex of the graph is at 0, -4. So the value of k, so x squared plus k, the value of k translates the graph of our parent function, our f of x equals x squared, vertically k units. So it moves k units. The vertex of the graph is at 0, k. In this case, 0, -4. And the value of k does not affect our axis of symmetry. Okay, so let's go on to our next slide. Well, now what happens if we have, instead of having f of x equals x squared, we have g of x equals x minus 3 squared. So you'll notice the axis of symmetry is now at x equals 3. So our axis of symmetry in our original graph was at x equals 0. Our axis of symmetry on our new graph is right here at x equals 3. Each point is translated right 3 units. So every point is translated to the right 3 units when we subtract 3. So the value of h in g of x equals x minus h squared translates the graph of the parent function horizontally h units. The vertex of the graph is at h0. So you notice it was at 0, 0. Now it is at h0. In this case, 3, 0. The value of h also translates the axis of symmetry. So h translates our axis of symmetry. It translates us horizontally. K translated us vertically. So now what happens if we combine these? What if I have something times x minus h squared plus k? So what information do the values of h and k provide about the graph? So the values of h and k determine the location of the vertex and the axis of symmetry. The vertex of the graph is at hk. The axis of symmetry is at x equals h. So if I actually had this live so we could play with it, you would see that as I slide my h left and right, my graph will go right and left. The thing to remember about h is because it's x minus h, it's always going to be sort of the opposite direction. So if h is positive, if it's x minus 3, we're moving to the right. If it's x plus 3, we're moving to the left. So we're going to talk about that a little bit more. And then k, of course, moves us vertically. So h moves us horizontally, that's why it's our x. K moves us vertically, that's why it's our y. So now let's talk about how can we use the vertex form. So let's use the vertex form to graph this. So here I'm graphing -2 x plus 1 plus 5. X plus 1 squared plus 5. So it is the same graph. So notice here I have a plus 1. And remember that we said that this is x minus h squared plus k. So I have to change my plus 1 to minus -1. So that helps you find h of -1 and k of 5. So I know my vertex is at negative 1, 5. So I'm going to cover my graph. I'm going to go to negative 1, 5, and I'm placing my point there. That is my vertex. I also know that my axis of symmetry is x equals negative 1. So I'm just going to highlight my axis of symmetry so we can see where it is. This is my axis of symmetry. In order to do more, I'm going to need to choose other values and put them into my equation to find other points. So let's try if x is 0. So I have negative, undo that, sorry. So I have negative 2 times 0 plus 1 squared plus 5. So I've got negative 2 plus 5, which is, not negative, sorry, positive 3. So that's my first point. It's going to be 0, 3. So I'm going to place that point. And I'm going to do one more. What if x is 1? This is another color, you can tell. So I have negative 2 times 1 plus 1 squared plus 5. 1 plus 1 is 2, squared is 4. So I have negative 2 times 4 plus 5 gives me 8 plus 5. Negative 8 plus 5, sorry, so it's negative 3. So my other point is 1, negative 3. So I can put that point at 1, negative 3. Now I'm going to mirror across my axis of symmetry these points. So this point here is going to mirror right over to here. Place that point there. And then the bottom is going to mirror right there. So you can see I have more than enough points to create my function. So I'm just going to connect my dots to make my parabola. And arrows, because of course it goes on forever. Ignore my horrible drawing, but you get the point. So let's go over one final example. Okay, so this real world example. So Deshaun and Chris are playing soccer. Chris takes a shot on goal. Deshaun is 3 feet in front of the goal and can reach the top of the 8-foot goal when standing directly beneath it. Can he block the shot from his current position without moving or jumping? So as you can see, the path of the ball can be shaped with a parabola. So we are going to approximate this path using the parabola defined by the quadratic function. You can estimate the vertex right here. You can see that the ball's hitting the vertex right there. The vertex is 1611. So we are going to write the quadratic function in vertex form. So first thing we need to do is we need to substitute in h as 16 and k as 11. So we get f of x equals a times x minus 16 squared plus 11. After that, we still need to find our value of a. So in order to do that, we can estimate the point where Chris kicks the ball. We're going to use that point to put in our x and our x and our f of x to find the value of a. So when I put in forgot to change back to that. 1.2 equals a times 2 minus 16 squared plus 11. I am going to first simplify, so I have 1.2 minus 11, I'm going to move the 11 over there, equals a times negative 14 squared. 1.2 times negative 11 is negative 10. No, sorry, not negative 10. Negative 9.8 equals a times 14 squared is 196. So I need to divide both sides by 196. Just come over here. So I end up with a equals negative 0.05, which means now I know my entire equation is f of x equals negative 0.05 times x minus 16 squared plus 11. So let's keep going. Now we are going to use the function to find the altitude of the ball at Deshaun's position. So we know that Deshaun is 3 feet in front of the goalpost, which is at 25 feet. So we know Deshaun is at 22 feet. Remember, that is our x value. So we're going to substitute in 22 for x. So I have f of 22 equals negative 0.05 times 22 minus 16 squared plus 11. Sorry, make this a little smaller again. So, f of 22 equals negative 0.05 times 22 minus 16 is 6 squared plus 11. So I have f of 22 equals negative 0.05 times 36 plus 11. Guys, of course, you know you can use a calculator for this because I can't do negative 0.05 times 36 in my head. So I'm going to use my calculator real quick. So that gives me negative 1.8 plus 11. So that gives me f of 22, oops, forgot my equal sign, equals 9.2. Okay, so that means that at Deshaun's position, the ball will be 9.2 feet in the air. Actually, slide there. Okay, so I have f of x is 22. So, if we know that at Deshaun's position it's 9.2 feet, that means Deshaun cannot block it without jumping or moving. Because Deshaun can reach 8 feet, but he can't reach 9.2. It's still going to be above his head. Be like right there when it goes over, and he cannot block it without jumping or moving. So go ahead and do your work on your Savas, and I will see you in class.